Hi guys, we said before that the base of any exponential functions cannot be negatives. That means it's always positive and different of one, and we said we're going to explain why there is these rules, conditions for any exponential functions. First of all, we have in front of us three examples of exponential functions, and all of them the base are positive. The base is 2 here, and the base is 1.5 here, and the base is e. Remember, e is a number, so this number is positive, so there is no problem for the example that we have in front of us, since all those bases are positive. And about the exponent, it can be x, it can be x plus 1. Don't care about the power, okay? We can have any expressions for the power, any x, any variable, but the base, to be an exponential function, the base should always be positive. So to understand why the base cannot be negative, we're going to choose an example, just one example where the base is negative. Okay, let's take an example. So let's say we have these functions where the base is -2. Okay, so we're going to try to give some value for x and see what happens for the range, for the result. Let's take x equal 1. If we have x equal 1, it's going to be -2 to the power of 1. The result is -2. Okay, let's say we have like x equal 1.5. that means 1.5. Guess what? If you use your any calculator, you put 1.5, you put -2 to the power of 1.5, you're gonna there no value for it. There is no value. Okay, try it. Let's take a calculator and take -2 to the power of 1.5. you will not have any value. Okay, let's say you take 2, you're gonna have -2 to the power of 2, you're gonna have 4. Let's say you take 2.5, 2.5, no value. So we can see there is some problem here. So there is some value that you can find. So we can ask a question: what if I take a value here? Let's say if I decide to if I decide to take a value here, let's say here, and before 1.5, let's say if I decide to take x equal 1.5, 1.25, 1.25. Try x equal -2 to the power 1.25. If you do it, no value. You can try also. Try from here before 2.5. Let's say you have x equal 2.25. Try it. So you have -2 to the power of 2.25. No value. So what I'm trying to explain you, for these functions, this means there is a lot of value between those two. Let's say if I have to go from 1 to 2, there's a lot of value that I will not find no value for them. So that's why we say this function is not continuous. It's not continuous, since if I try to plot it, if you try to plot it, let's say for 1, you're gonna end up with -2. I know for 2, I'm gonna end up with 4. Okay, those are the two values, but I cannot draw a line here because I don't have any value for 1.5, 2.5. I don't have any value here. So this function is not continuous. So if you try to plot it, you're gonna have just some point like this. You're gonna have just some point, just like this. So this function is not continuous. So there are a lot of value between those two integers that between 1 and 2. If you 1.5, there's a lot of value here that you're not gonna have any result for them. It's the same also between 2 and 3. There are a lot of value here that you will not have any result for them. So this function is not continuous. So when you have a function like that where the base is negative, it's not continuous. You can try it also with between 0 and minus between 0 and minus 1, between 1 and minus 2. If we try to plot to give, let's say if I have 2 minus 2.5, you're not going to have any results. So that's why we say for exponential function you can have the base negatives, because the function you're going to have is you're just going to have some point like that. You see, the function is going to be different point. You can really plot it. It's really difficult. You're going to have different point, so it's not continuous. I hope you understand why the base. I just took an example and I take some value. For 1 I got minus 2, yes, but for 1.5, 1.5 I don't have. You see, try it with, you can try it with 1.5. You're not gonna have any value. You can try it also. You can try it with value between 1 and 2, between 2 and 3. You're not gonna have any result. That's why we say the base cannot be negatives. Okay, you understand? Now we're gonna try to. We say the base should always be positive, but it cannot be 0. It cannot be 1 also. Let's understand why the base cannot be 0 or 1. Let's take an example. Let's say I have. I'm gonna take an example where the base is 0. Okay. Let's say I have fx. I'm gonna take the base 0 to see what's gonna happen. The base is 0. Let's say I have 0 to the power of x. For this function, understand, whatever the value you decide to take to x, let's say x, 1, 2, 3, minus 1, minus 7, whatever the value I take for x, the result I'm gonna get is gonna be the same. It's gonna be 0, because 0 to the power of 1 is 0, 0 to the power of 2 is 0, 0 to the power of 3 is 0, 0 to the power of minus 1 is 0. So whatever the value I take for 0, the result always gonna be 0. That's why we say that the base cannot be 0. So in fact, the functions, if we try to plot it, plot, what we're gonna have is like whatever the value for x, whatever the value I took for x is gonna be 0. So I'm gonna have this line only. Okay, quickly, let's say finally, why we say the base cannot be 1. That's the same example also. Let's say I have f of x equal 1 to the power of x. It's the same. The same. So if I have x equal 1, 0, 2, minus 3, whatever the value I take of x, the result gonna always be 1. I'm gonna have the same. Okay, the same. That's why. I hope you understand. See you for another video. Okay, I'm coming. Give me a second. Okay. Yeah.